everyone, welcome back to another great section of this tutorial class. Today I'm going to take you guys through a very important aspect of physics, which is the superposition principle of electrostatics. So remember we looked at electrostatics. We said it's the study of charges at rest. Whereby a charge body can be moving or it can be at rest. When we are studying when it's moving, it leads to us to current, electricity. But when it's not moving, just in one place, we call it static electricity or electrostatics. So remember, charges can exist in two forms, can either be positive or negative. Also remember that two like charges we tend to push or repel each other, and unlike charges we tend to what? Attract each other. So remember that it's still very, very important. There are also remember Coulomb's law, which says that the force of attraction between or repulsion between two charged bodies is direct proportional to the magnitude of their charges, the product of their magnitude, and inverse proportional to the square of the distance apart. The force of attraction or repulsion between two charged bodies is direct proportional to the product of their magnitude and inversely proportional to the square of their distance apart. Now, remember Coulomb's law typically stated two charges. That's the problem we are having now. Because in this question we are having three charges. So how are we not going to resolve this? Or how are we going to unravel this mystery? So we are going to come from a principle that we call the superposition principle. Now, superposition principle helps us to evaluate or analyze charges or forces between charged bodies that are more than two. Coulomb's law will analyze forces that are just two. Then, superposition principle will now come from Coulomb's law to analyze forces that are now the forces between charged bodies that are now more than two. If the charges are now more than two, will come from superposition principle. Now, what is this principle? What is this principle? So please ensure you have subscribed to this channel, because that is what gives us more energy to continue. Because we thank everybody that subscribed so far. Though you have not subscribed yet, please try and do so. Just take a break now, run through this, just subscribe. You know you are not registered with YouTube, just register in the value given and subscribe, so that you have the joy or energy to do more videos. We know that you are going to gain from this class. We know you have been gaining from this channel. So please help us, just subscribe to this channel. To do so, God will bless you. So let's go back to this. What is this people actually talking about? Now listen, a very simple way. The principle states that the force exerted on the charge due to other charges is the vector sum of the current forces acting on that particular charge due to these charges around it. The force exerted on a particular charge due to other charges is the vector sum. The actual force is the what? Is the vector sum of the Coulomb forces. Remember, Coulomb force, not Coulomb force. Coulomb forces means it should be more than one. If the charges are more than two, the forces should be more than one. So, of the Coulomb forces acting on this charge due to these other charges around. In a very simple way, if I want to ask you now a question like that, I want to say, what is the force that's acting between them? But the word force is exerted on our measure the charge. Then you use the principle to apply Coulomb's law to resolve the force. So what I going to do, we will take the force. Okay, like for example, let's say calculate the force on Q2. Let's say calculate the force on what? On Q2. Let's say calculate the force on Q2 now. From this principle, the force exerted on Q2 is the what? Is the vector sum of the Coulomb forces acting on this Q2 due to Q1 and Q2. That's what we're going to do. The force exerted on Q2 is the vector sum of sum. Vector sum. Sum means addition. What about vector sum or vector addition? Vector addition means you take note of the magnitude and direction. Vector sum we are talking about is actually not just the normal sum, addition, subtraction, mathematics. No. We are talking about the loss of adding vector quantities, which can either be the parallelogram law, or we can also use resolutions of vectors. That's what we are talking about in this case. And then the parallelogram law or the resolutions of what? Of vectors. So the major one I'm using here now is parallelogram law to just calculate the magnitude of the vector or of the forces acting on this particular chart. Then I can also take you guys through what I call resolution of forces. So in this first question now, I'll just use parallelogram law to just obtain the total force. Then maybe I'll give you another question. I'll use the resolution of forces to also do that. They are not actually hard. It's just for you to get the analysis and the mathematics or the actual explanation and the knowledge behind the law that I'm actually talking about. So that's what we mean by that vector sum. You will that's the meaning of that vector sum. So let's look at the first one, Q2 now, that is coming from either Q1 or Q2. The first thing you do, you check. What's the nature of Q1, Q2, Q3? Q1 positive, Q2 negative, Q3 positive. The next is to check. Now, between these two, between these first two charges, now how will this react to this? Will this charge attract this one? Will it exert a force of attraction on this or a force of repulsion? Remember, force of attraction will bring it closer. Force of repulsion will take it closer. The force of repulsion will push it away from particular charge. So now that this one is positive and negative, it must attract it. So this one will be attracted to this. And that's the force. This one is a frequency due to this. It's a force and it's being what? A force of attraction. So this one will be trying to what? Attract this. So it's going to be coming towards the Q1. So we can call this one the first one Q2 coming from Q1. First one Q2 coming from Q1. Then let's check for this. Will this one be attracting this or be repelling it? So it's positive. So it's negative. This one will also be attracting it. Because we are looking for the force. So this is the actual charge that is being attracted or repelled. Because they said calculate the force on this one. So this one will also be attracting this one to itself. It's like they are dragging it. So the first of Q2 coming from what? Q3. It's like they are dragging it now. So let's say what? Look at we're already having two forces. So I've told you before. If the jets are more than 3, we are going to have more than one force. So what is the force of Q2 now? We have one force, we have two forces. Then we are going to add this to this using vector addition or vectorially. So I'm not sure how to add this to this vectorially. It's very simple. We might not just be stating formulas yet. So let's go and see what we're going to be having. So our F2, 1 will be K, Q1, Q2, Q2, Q1 over R squared. The Q is in capital letter, so let us put it in capital letter. Over square. What is the arrow? What is the distance between Q2 and Q1? Q2 and Q1, arrow 1 square. So this is how you are going to calculate the magnitude of the force. Inside of the force. What about the other one? 2, 3, then we are going to be having K, Q2, Q3 over arrow square. Which of the arrow between Q2 and Q3 is arrow 2 square. So we are going to calculate this first force this way, calculate the second force this way. Then we are going to add together. How are we going to add together? Add together. The total force on the net force will be equal to the net force. The net force will just be equal to. Now from here now, in resolution of forces, look at it. In resolution of forces, you have something like this. You have to bring the force to what we call a Cartesian coordinate. Bring the force to a Cartesian coordinate, which is a type of form like a plane coordinate. And this part is minus x, this part is plus x, this one is minus y, this one is plus y. So for the x direction, this one is only moving in x direction. For the x direction, any force traveling towards the negative x axis. Now if you check yourself now, because the negative x axis is actually the left hand side, then the positive x axis is the right hand side. So I can just say in a very layman language, any force going towards the left will take the negative sign. Any force going towards the right will take the positive sign. So since it's a vector, so what is the total force now? What is the net force? So this one is going to be going means look at it. A vector is always represented with the straight line and an arrowhead. The arrowhead will tell us what is good. If I say A, B now, this one is moving from A to B. That's moving from A to B. If I change this arrowhead, if I change the arrowhead now, this one is moving from B to A. So that's because direction. The line tells us the magnitude, the arrowhead will tell us the direction of the vector actually. So this one now is going towards this side. So that is the left hand side. So that one is going towards this side. That is the right hand side. So please take note of that. So we're not going to take left, F2, 1, right, F2, 3. That's how we are going to add it. So it's not always like this. You also have a case in which both of them will be going towards this side. Both of them take positive. If both of them are going to the right hand side, we take positive. If both of them are going to the left hand side, we take negative. But if one is going to the left, another one is going to the right, the one that is going to the left hand side will take negative, while the one going to the right hand side will take positive. Please take note of that. So let's start a very typical question now. Then we are having plus, minus, plus, minus, plus. Then let's say we have 4 microcoulomb, 3 microcoulomb. Then let's say we are having 6 microcoulomb. Then from here to here, so let's say this one is 2 meters, okay, 2 cm. Let's say we have this one is 3 cm. So what will be the force? What will be the force on the minus 3 microcoulomb? So that is negative, that is positive, that is positive. So that's what we are having now. That's what we are having. So how do you solve this question? The first thing you do, come and check which one is the minus 3 equality and mark it out. That is minus 3. Next, how will this minus 3 react to this? It will be attracted to it. That will be the first one, that is the first one. Let's go around F1. Or you can just lay this, there's no length of label. You can't just label it. At least have the label to explain everything. Now, just okay, what about this and this? How will this one react to the cover? Let me force on this. If you check then you will discover that in this first force, Q2 was showing. Second force, Q2 was also showing. So the one that I calculate the first one will be showing in both of the forces that will be present. All the forces that will be present, that particular charge will show up in all the forces. That is the first way to know that you are doing the right thing. So we are going to have for the second one, what is between 6 and minus 3, this force also attract this minus to itself. Let's go on F2. So what is the F1? And F1 is found between this and this. And remember that this one is 4 times 10 to the power minus 6 coulomb. You have not watched our first video, go and watch it. This symbol means minus 10 to the power minus 6. Then this one is minus 3 times 10 to the power minus 6 coulomb. That is minus 6. Then this one is 6 times 10 to the power minus 6 coulomb. So that's how we convert them to coulomb. You don't use microcoulomb actually to solve. When we are using this, remember we are using that key is the coulomb. Newton meters for the coulomb square. So we're going to convert everything to coulomb. And again, you are going to apply or put the magnitude of these charges here. Don't put sign to them. Don't add sign to the charges. That's what I'm going to say. But the first one is not between this and this. This is the plus 4 and minus 6. I'm going to do Q times Q over R square. What is one between them? That is 3 cm. If I want to move from 3 cm to meter, divide this one by 100. We will have 0.02 meters. The same thing, move from cm to meter, divide that by 100, 0.023 meters. That's what we're going to be having. So please take note of that, it's very, very important. What are we actually doing? We are looking at the force on Q3. How do you look at the force on Q3? Check other charges around. Will they attract the Q3 or repel it? This one will attract it. So that one will also attract it. So that's the first thing. So the next thing, what is this force of attraction between this and this? What is this force of attraction between this and this? How do you calculate the force between two charges? Okay, Q1, Q2 over their distance square. How do you calculate the force between these two now? Okay, times this over their distance square. This is how to calculate it. And as I said, what is the force on this one now? I said, what is the force on this? Calculate between this and this, and between this and this. But I said between this and this. Now, what is the distance between these two now? With this one plus this one. Is from here to here. So that's how the thing is. Use the right distance calculator. But for this one, I just calculating this and this. Because I'm looking at the first one minus 3 microcoulomb. So I from B. Okay. What is K? Remember K is 9 times 10 to the power 9 times. Then what is the first charge here? 4. That is 4. Times, don't put the sign with them. 10 to the power minus 6 times what is the second one? Minus 3. So this minus will not appear in this formula. We pick only the magnitude or the value. So the minus tells us whether it's going to attract or repel. That's what the sign will tell us. So we are going to leave the minus alone. Just pick 3 times 10 to the power minus 6. Then over. What is the distance between this and this? The distance between 4 and 3. and this one is going to have 0.02. Remember, is their distance square. So we have our answer here. We have our answer. And the next one, our F2 will be K 9 times 10 to the power 9 times we have 3 times 10 to the power. F is between this and this, that is F2. 3 times 10 to the power 6 times 6 times 10 to the power 6 over 0.03 square. Remember, we don't add their sign to the chart. Don't add their sign. Just take the magnitude only. This thing of that is very, very important. Now, after you have gotten the answer now, so we go and apply the first value. You want to go to the left, take negative, go to the right, take positive to find the final thing. So that is all. Alright, for your calculator, do this, we have 270 newtons. Run this, we have 180 newtons. Now, what is not the actual force acting on this? Apply that addition rule or the vector summation rule. So we're going to have the net force on Q2 to be equal to, which one is going to the left? F1. So I'll take a negative sign. Then we can go to the right, F2, I'll take a positive sign. So F2. So we have in, what's F1? Minus 270 plus 180. So that's going to be giving us, when we have something like minus 90 newtons. That's the actual force. So the magnitude of this force, is 90 newtons, and the direction is with what? The negative minus x axis. That's what it's going to the negative x axis. Or it's going to the left. It's going to the left. Go to the left hand side. Go to the left, or it's going towards the negative x axis. So there's another question I would like us to look at now, for question 2. So that in case they are not linear and moving in form of, let's say, a triangle or so on, how are we to obtain the force? Let's assume we have this type of question, and we have to calculate the force on plus 10 microcoulomb. Where this is plus 10, this is plus 20, this is minus 30. So we calculate the force on the what? Plus 10 microcoulomb, which is this. How are we going to do it? How will we obtain that stuff? Still the same way. First thing, check the nature of the force. The charges is positive, negative. That's the first thing. Then, secondly, you now check which charge is in the question. So you have to calculate the first one is, so you mark it out, is this one. So you mark it out. So what I'm trying to say now, we are trying to say, with this minus 10, with this plus 10, we are trying to do this one, or we repelling. What force is going to happen? Or what force is going to be between this 10, 20, 10, and 30? I already told you, two the same charge, unlike charge, we repair, then unlike charge, we attract. So this minus 20 we attract this plus 10, then this plus 20 we repair this plus 10. The next thing, to calculate the force of attraction that is there, the force of attraction, then add it together vectorially or using vector addition. So look at where we are having the force, here. Look at what I'm trying to say. This one now will be repelling this one up. Repelling this one up like this. Repelling this one up like this. This one now will be attracting it. That's what I do. This will be repelling it. If you are following, this one now will try to repel this one upwards. Then while this other one will attract it toward itself. So we're going to call this one F1, call this one F2. So things are very important here. We have to know this angle. So this angle is also alternate to this other angle here. Alternate to this other angle is alternate. This and this are alternate angles. Then that alternate angle, this angle is vertically opposite to this one. So this one is also so that is very important. It's very important to know that. This angle is totally to this, and this one is right parallel to this. And the same thing. This and this are the same. This is totally to this, while this is vertically to this. So please take note of that. It's very, very important. So what is this angle actually? This angle is opposite to our adjacent. Very angle. It's a very simple thing. Now what is this angle between 10 and 20? We know that this one is 3, this one is 4. What is the distance between this and 2? We have to read the distance. So what is arrow here? Whether the distance between this and this 4, what will be this distance here? That arrow will be the square root of. Remember, you have to do like this. From Pythagoras theorem, you have to do like this. This is don't know. Like this. This is what we have here. So let's study hypotenuse. That's A, B, C. ABC. Then, if you square this one is called the hypotenuse. If you look at this angle on theta, this one will be opposite. This one is hypotenuse, but this one is facing angle 90. One is facing the angle 90. So this one is facing this side, that's facing this angle 90 is called hypotenuse. Then this one facing this angle in question is called opposite. The remaining side is called adjacent. If you are looking for this angle here, this one becomes opposite, this one becomes adjacent. And the angle will not be there again. Now when I keep this angle, now move to this place. So we become opposite, side remain hypotenuse because it's always side to side relative and we talk to the adjacent. So let me draw the same shape as here. This will happen theta in this place. So if you square this hypotenuse, it will be equal to the square, sum of the square of the other two sides. That's why we will have it. So that you now have C to be the square root of B square plus B square. So we will have it. So if you square this one will be equal to the square root of this one square plus this one square, which is 4 square plus 3 square. So now we will 5 meters. That's why we will have it. This is 6 plus 9, that's 5. Total of 5 equals 5 meters. So the distance between, let's place on our arrow 1, then let's place on our 1 for our arrow 2. So please take note of that. The next thing we can make our F1 and our F2, then we'll bring it to somewhere here. We'll bring it to somewhere here. You're having this, you're also having this. This is F1, that's one is F2. So please take note of that, it's very, very important. So from here now, we just get some theta, get down the theta, then we resolve. We resolve it, we get axis, and we find the resultant force. Then we are going to do. Now let's calculate F1. What is F1? Our F1 will be equal to K, Q1, Q2 over rho square. So let's this one, let's this one, let's this one, okay, let's this one Q1, let's this one Q2, let's this one Q2. Let's one Q2. So take Q1, Q2 over the distance will give us F1. Then for this other one, we take times this over the distance square. So you solve this, and we have it. What is our K? 9 times 10 power 9. What is our Q1? Our Q1 is 10. Expression minus 6. We got that minus there. What about Q2 20? Expression minus 6. Then over. What is our distance? 5. Minus 5. So you have your. Remember the distance are in meters, so they don't convert. So remember that one is very important. So we saw that you have an answer. What about F2? Before between this 10 now and this minus 10, this and this. That's our F2. That will be K, Q1, Q3 over arrow square. So what I will have here, because it's arrow 1, it's arrow 2. So what I will have here, we have in K to what? 9 times 10 to the power 9. Times, what's our Q1? 10 times 10 to the power minus 6. What about our Q2? Minus 30. Remember, usually 30. I'm going to include the sign. Then over. The distance between x and x is 4. So that you get your answer. You get the answer for the Q1, the F1, you get the answer for our F2. So we are going to have this answer. So we will have 3.072 88 this will give you 0.169 inches. So next thing we'll be doing here is to add this to this using either parallelogram law or you use resolution of forces. Now I'm going to teach you first how to use resolution of forces, then maybe I'll also solve it using parallelogram law so I will check it. So look at it. For resolution of forces, first you will get this angle. Remember I told you that this angle is not to this, direction is practically opposite to this. So this and this will be the same thing. The taking of that is very important. Very important. So what I'm going to have here, to get this angle here, that angle, tan of that angle will be equal to opposite. Opposite means the side facing the angle. Opposite means the side facing this angle. The side facing the angle is 4 meters. And the opposite, that is 4 meters. Then over adjacent. Now this side facing this right angle triangle or the side facing the angle is the hypotenuse. This other one will be the adjacent, which is 3 meters. It's 4 over 2. So theta will now be equal to tan inverse of 4 over 2. So what will be our theta? From there, we will get our theta. So we'll be equal to that theta. Now from Casio, calculator, you check your calculator, the Casio calculator, we're going to be having tan inverse of 4 over 3. Tan inverse of 4 over 3 will be equal to 53.1. 53.13. So we're going to have 53.13 degree. That's what we have. So let us call it approximately 53.1 degree. Or let us say approximately 53 degree. Let us call it approximately 53 degree. Because of so I'm not about to write too much stops. So using resolution of forces first. Using resolution of forces, I'm going to add this to this one. How do you add? You can have to do it. Now you're going to resolve. Remember this one is I don't put this one in here. So that it will look like a Cartesian coordinate. You just draw a Cartesian coordinate to the force. Just draw like the way you have the chart in question. Just draw like cross there. And that's something I have to show. And when we look for this one, I'll just draw the thing there. Then something like that will show. Maybe be going down or towards the other side. So the next thing, this one now, this is going to the y-axis. So this one already the y-axis. This one is going to both y and x. Remember this side is negative for s, side is positive for s, positive for y, negative for y. What we are going to do now, we are going to break this one into both x and y. It's called the component of f1. Component of f1, which is the amount of f going to the x and the amount of f going to the y. So look how we are going to do it. For the x direction, which force? What is the force in the x direction? The force in the x direction will be, look at it, let's go to the negative side. So if I take the minus side, this is negative f1 cos the angle theta between that f1 and the x-axis. That's how we do it. To get to remember, just something like, take a look of this. I want to find the component of the force in a particular quadrant. We have first, second, third, and fourth. We have first, second, third, and fourth quadrants. So we have quadrant. Any quadrant. So the first you check, if it is in the x-axis, you check, is it going to the left or right? If it is going to the left, you put negative there. That's why it's going to the left. And the next thing, you use the force to multiply the cos of the angle between the force and the x-axis. That's what you do. Use the force to multiply the cosine of the angle between the force and the x-axis. So you get the answer. Now, what about for this other one that is going to the y-axis? Now, anyone that is going truly to the y-axis, there's no need of adding down to the x component. If it is along the y-axis, don't leave it. That's going for the x component. Now, for y component, if something is along x and look for the y component of that force, leave it. The y component will be 0. Now, this one now, that is truly y-axis, the x component of that will be 0, which will actually be f2 cos 90 and cos 90 is 0. So we don't need to, this is going to the y-axis, don't need to handle it. So that we have it for this, our f1 is 0, as well as 0.072 cos, and our theta is 53. So we have answer for this. Then, what about the summation of all the forces go to the y direction will be, this one is to the upper side. Take a look at this is the upper side. So we are going to do to get the y component of F1 now, or the amount of y, the amount of F1 go to the y direction now. Remember, to get the amount of F1 go to the x, use F1 to multiply the cosine of the angle between F and x axis. Now, to get the amount of F1 go to the y direction now, what are you going to do? Use this F1 to multiply the sine of the angle between F1 and x axis as well. So that it will be F1 sine of that same theta. Theta here and this theta here will be the same, but this one will be cos for x, this one will be sine for y. That's the only thing that will change. The other thing will be the direction. You check, is it the upper side or the downside? For upper side, y is positive, for downside, y is negative. So it's the upper side, so it will be positive. And positive. Then let's check for the next one, is just going truly the y axis. So we have, and it's going to the downside, that will be minus F2. You can just say F2 sine, the angle between this F2 and the x axis is 90 degrees. Sine 90 will give you 1. So there's no need of using this one to multiply any angle. If it's just fully y, just add or subtract it. Like that, don't use to multiply the angle. If you see just we are along the y, we are looking at the y components, or the amount of forces goes to the y direction. But if something is moving, like another force of moving here now, when we're doing for f, when we're doing for x direction, what we just do for this, remember, to do for this one now, just multiply the cos of this angle. The position now, we just enter subtract. See now, this one go to the right hand side, will be close to this one. We don't multiply the angle. Since it's moving along the x axis. But when we are not doing for y, this one moving along the x axis will be 0 for y. But for x, this one moving along the y axis will be 0 for x. That's how please take note of that. It's very, very important. So the next thing will be, let's bring out the values. We have plus 0.072 sine 53 minus 0.169. This will also give us answer. So the total force now, or the net force will be equal to, again the net force will be equal to the square root of the f of x squared plus the f of y squared. That's how it is done. The f of x squared plus what? The f of y squared. So that will be the magnitude of the net force. The magnitude of the net force. Or let's try to do it like this. Let us bring it. Let us do it one after the other. So to get the first one out, we catch our calculator, just run through them. Let us run through them. Let's check and see what I will have. Minus 0.072 cos 53. Cos 53. Which I will have. I'm having here minus 0.042 newtons approximately. The let's check for this other one. For this second one, we have 0.072 sine 53 minus 0.169. So I'm having minus 0.1115. So let's see, let's approximate something like let's leave like this, and let's add 1 to these 3 digits. So that the first one was 3, and so trying to be in 4 decimal places. I hope you are following. Just try and follow, because this is actually due to some strength. So that goes on and get it better. So at the end of the day, we are going to be happy. Remember, this one is still going to the downside for y. So it's going to the left side for x. So we're going to have something like this. Something like this. So it's going to the left side. So that the other one is going to the downside for y. The downside for y. This one is 0.115. That's actually 315. This one is 0.0432 newtons. So this is what we are going to have. The next thing, to get the direction now, to get the resultant, what you just do, just complete this one form of a rectangle. This line will be the resultant force. Will be the resultant or the net force. The net force, that will be the net force or the resultant force. So the resultant force now will be, the resultant force will be equal to from also Pythagoras theorem. The resultant force will be equal to the square root of the f of x squared plus f of y squared. So it's going to give us 0.0433 squared plus 0.1115. Don't include the ascending. That will be equal to square root of 0.0433 squared. 42 squared plus 0.1115 squared. So I'm having 0.11. Okay, let us say 0.12 units. So that's what I'm having as the net force, or the magnitude of the total force, the magnitude of the total force. So if you add this to this now, using this method, this one that we are just adding. Or you can also say our resultant force is equals to which one is equal to the x direction? Minus 0.0433 in the x direction minus 0.1115 in the y direction. So the resultant force is this one. Now what is this? I'm going to do this one. This one is vector form. So I'm going to do the x, this one is going to do what? Y direction. Then to look for the direction of the resultant now, we just take the tan inverse. Now, if I want to take the direction of the resultant, we actually go to take it from this positive x and we like to take this something like this. So that direction and theta. The first thing, we want to have to do for this one. Let's call this one alpha. Let's call that one alpha. You see what I'm doing alpha. Let's call that one alpha. So the alpha will be the tan inverse of opposite to that side. Tell us this opposite over adjacent. Now, it still works with the complex number we did. Remember, if the real and the imaginary are both negative, to look for theta will be 180 plus tan inverse of v over 8, something like that. And it still works that way. Use the real. Remember, the imaginary was the y-axis, the real was the x-axis. Just something like that. That's what we are doing now. So I don't want to just do it one after the other. So for the f of y over f of x. This is the formula for calculating the direction of the resultant. But this one is clear at the technical. So what we have to do, we have to calculate this theta first, we have to calculate this angle first, then we'll add it to 180 to get the theta angle. Now we have tan inverse of, let's just see we have 0 points. Don't put the signs there over 0.0422. So when we have something like, let's check out what we have, tan inverse of 0.1115, then over 0.0422. This one we have here. So I'm having approximately 69 degrees for this. So the theta will be 180 plus 69. This tan inverse of v over e. So the other theta is 180 plus tan inverse of v over e. If a and b are negative, consider that number will be. So plus 180 plus 180 that was 249. So if you still use this magnitude of the force, you'll apply something like this one. The cos of this. So we run for the cosine. We have x-axis. You see not the cosine of this one, you see what happens. I'll just try it. You see what I'm going to happen. I'll try to see what I'm going to happen. There's 0.12 plus 249. So I think we're having 0. Minus 0.040. So think about that. So it shows we are actually moving in the right way. So this is the absolute direction from the positive x-axis. Then this is the resultant. Now to get this resultant from Parallel law, so you have to do it using Parallel law. You don't have to follow this because this one is actually somehow always know this registration process. Let's not use Parallel law. Just use this law. Which is the resultant force will be equal to the square root of F1 squared plus F2 squared plus 2F1 F2 plus theta. Now this plus here can be sometimes minus. Now I'm going to be running through a vector class during our next class of physics. I will show you why this one will be close or why that one will be minus. Since you are just looking at this product for now, I will explain that for now. So let us apply it directly. But in this angle, this is the angle between F1 and F2. Angle between this and this. This is actually this angle. Yeah. Let's do that then. So how I will look for this angle now? This full angle will be this plus this angle here. This quadratic angle is 90. And this full angle here for this one. This one is already 53. Plus 90. That will give us 143. That's going to give us 143. 53 plus 90. That's going to give us 143. 142. That's what I have done. So the resultant force will just be, without wasting much time, just the square root of y is equal to 0.072 square plus y is equal to 0.169 square plus 2 times 0.072 times 0.169 plus 142. That's what we have. So if you solve this one, you have to use your calculator. Although this one can only give you the magnitude of the letter, can actually give you the direction. Exactly. Although you can give you the direction, you now apply sine rule. Now apply sine rule, you get the direction. But it will not be that very easy. Because the direction of this one is very easy to do. But the direction of this one is very hard to do. But the resultant of the magnitude of the letter for this is very easy to do. But for this other one, the magnitude of the letter is very long. That's just it. Although you can still get the direction you want to get it, but I will not be doing that. I'll just get the magnitude of the other and pull it. That's what I'm just going to do now. So we will have 0.12 newtons. This is what I'm going to have. If you check this, and the same thing. So this one is very short. Very, very short. This is my law for calculating resultant. You don't need to be looking for f of x, f of y. What you have to do is just to get the angle between f1 and f2. Just apply the formula, you just get the answer. But to get the direction for this, the thing will now have to. Although if you check our channel, if you check this channel, there's one video that is according to this channel now. It's just Paragon law, Paragon law of forces. Check it. I saw something like this using Paragon law, and now use it also look for direction. But this one is mainly used for calculating magnitude. You want to be very fast. You get the direction will still be somehow complex. But the direction of this one is actually simple. So thank you. Try and practice. Watch the video again over and over again. Make sure you get it. Then try your hands in questions challenging in your respective textbooks. God bless you. See you guys in our next class.